everyone. My name is John Connolly. I'm with the Conesus Lake Association and the Watershed Education Center group that puts these programs together. And just before we get started tonight, I wanted to let everyone know that we have a really interesting program coming up just about exactly a month from today. It's going to be Thursday, October 17th, right here. We have a professor from the University of Rochester who is an expert on magnetic fields, and we did kind of a really interesting poster. It's going to come out tomorrow, and you'll probably have a chance to see it. And she said that without magnetic fields, there would be no water, not only on the Earth, but on other planets. And she's also going to talk about the influence of magnetic fields on such things as the aurora borealis. And since we're now starting to see them in our area, I think it's going to be very interesting program. So that's October 17th. Before we have Dr. McCaffrey come and speak tonight, I'd like to invite Mary to come up briefly. We're going to tell you a little bit about a program that we're doing with the Watershed Management Council.
So my name is Mary Underhill, and I'm the Conesus Lake Watershed Manager. And we are in the middle of updating our Conesus Lake Watershed Management Plan. So this is a pretty big deal for us. The plan is about 20 years old. It is a guidance document, and we have the opportunity to bring it current. And one of the most important features of the plan is the opportunity for public input. This really would drive our vision, our recommendations, the actions that we want to take, and we want our folks to participate as much as you guys would like. And so we are doing a ton of outreach. We did mail out postcards to all lake residents, lake owners, and businesses in the watershed. We've been at multiple public venues, and the CLA Arts and Press Festival, Autumn in the Village. We're planning on taking our talk to boards and village town boards. If there's a group that you would like to get engaged, just give me a call and we can bring our group out, or that's me, bring our group out to have a discussion with your group. And it's really at this point, I mean, this is the time when we're working on the draft. In the next couple of months, we're going to be trying to firm that up. So that's why our public outreach right now is so critical. And I'm looking at the crowd here, and I can tell you that got a number of people in the audience that have already participated or I know will participate. So I'm really speaking to the choir and at this particular group. But what I would ask you guys to do is, if you've gotten your opportunity for input, please share it with your neighbors, your friends, your coworkers, so that we can really address what people would like us. If we only do this once every 20 years, this really is, we're setting our vision for the next 20. So how many of you guys actually received a postcard? A couple. And how many of you guys have seen our signs across Livingston County? I put one outside right by the door. It's right there underneath. It's got a blue sign. Has anybody seen our signs? Trying to see how we're reaching the public. Does anybody have another idea of how you would like us to do some outreach? Anybody put you on the spot? What I would like for you guys to do is think about it. If you think that we should be doing something additional, please reach out to me and let me know, because we have the opportunity to. Turn it back over to Louis.
All right, great to see people still coming in. So can you hear me at the back? Can you understand my accent at the back? Right, I'm originally from England, if you haven't guessed. And I arrived in the US in 2012 with my wife from Liverpool, New York, not Liverpool, England. And we met out in Angola in Africa during the Civil War. So we came over here after living in the UK for 10 years. And I've been here ever since, got my citizenship in 2017. And so my background is I'm a geologist, a hydrogeologist, and I've now been turning my attention to lakes and the associated problems. So tonight, I'm going to talk for about an hour, if that's okay. And I'm going to leave some time, 10 minutes, 15 minutes for questions. So if you do have any questions, write them down, put them in the memory bank, and we can talk about them at the end. So I'm going to talk about harmful algae blooms and how to mitigate them, particularly for New York State. Now, I work in a unit called the Finger Lakes Watershed Hub, and we're part of Division of Water at DEC, and I have to give my colleagues a lot of credit for this talk. It's compiled from a bunch of their talks. So Matt Kraft, Brian Duffy, Stephanie June, and other people in DEC have contributed. So what I'm going to talk about in broad sections is I'm going to give you an introduction to harmful algae blooms, or HABs. I'm going to talk about the different ways that you can mitigate against HABs. And that's divided really into two parts: how to keep nutrients on the landscape and prevent them going into water bodies. And if you do have nutrients in your water bodies, what can you do about the results of that, which are harmful algae blooms? I'm going to very briefly look ahead to what we might be doing in the future. So let's look at HABs to begin with. Now, hands up here, who's ever seen a HAB? Anybody ever seen a HAB? I'm sure that's the reason why you're here, right? You're concerned about them. Some people call them algae, but actually the one that we're most concerned about are cyanobacteria. But both types of organisms have some common features. They often have chlorophyll in them. They're waterborne, obviously, and algae and cyanobacteria can either be freshwater or sea water based. Cyanobacteria in particular, though, are very specialized. They have been around for billions of years. In fact, thinking about my geology, the rocks underneath our feet, a couple of 100 feet down, it's the limestone, Onondaga limestone, Heidelberg limestone, 400 million years. They actually contain fossils of cyanobacteria. So those cyanobacteria nowadays, they can regulate their buoyancy, they can move up and down the water column. Some of them are able to fix nitrogen, and they also have other pigments apart from chlorophyll, like phycocyanin and phycoerythrin. On their own, when they're in balance with everything else, they don't seem to be too much of a problem. But when they proliferate out of control and produce dense concentrations, they can cause harm, as per the name. And the kinds of harm are aesthetic. You know, people love a nice blue lake, but they turn the lakes green, or a particular cyan hint of green. They can cause economic damage. So lakes with large amounts of HABs have been shown to have decreased property prices. They can also have problems in terms of health impacts for people. So these cyanobacteria do produce toxins, which I'll talk about in a second. And they also can produce ecological harms. When those blooms die, they rob the oxygen from the water and cause collateral damage. So they are hard to predict. The causes are not fully understood. They do have a season. We're right in the middle of HAB season. You know, it's September to October, August, September, October. Some lakes, however, bloom all year long. Luckily, not the Finger Lakes. And like I said, that they're a natural phenomenon, and that buoyancy is one of the issues. So they are buoyant, they rise to the surface of the lake, and then once you have a gentle wind, it blows it into a very thick scum, which can accumulate in coves and against docks. So there's a natural phenomenon or a natural process which is concentrating these cyanobacteria. I mentioned the cyanotoxins. We can have a variety of different toxins associated with HABs. Liver toxins, nerve toxins that are generally inside the cells. There are also some toxins on the outside of the cells which can cause skin irritation. And there are some relatively exotic toxins associated with cyanobacteria, which are not common in New York, thank goodness. Cylindrospermoxin, saxitoxin, and so on. The difficulty is that there are no visual clues. If you look at a HAB, you can't say whether it's toxic or not. And that leads us to some ways that we're going to manage those HABs, which I'll get onto. Mechanisms for toxin production are not well understood, and there's still plenty of research into that. Something that I'm really interested in, but not really qualified to talk about. So the primary drivers of HABs in New York State, phosphorus. Phosphorus is the limiting nutrient. It's the nutrient which is in the least amount of supply. Because of that, if you can decrease phosphorus, you can decrease the amount of HABs, in theory. We've also found that zebra mussels, quagga mussels, their presence increases the amount of HABs in a water body. Lake fetch and the orientation of the lake in relation to the prevailing wind. So if you have a long fetch, meaning the length of the lake in the direction that the wind is blowing, a long fetch allows that, that concentration action to increase. So along with sunlight, obviously these are photosynthetic organisms, they need sunlight. They need calm conditions, or just slightly, 1 or 2 miles an hour they love. And those warm water temperatures. In fact, just like this week, right? On satellite images, the Finger Lakes have really lit up this week. And surprisingly, Seneca Lake, the largest Finger Lake, is really in the top 5 miles, it's green. But anyway, phosphorus, out of all of these, is the only one that we as humans can really control. And so that's going to be the main focus of what can we do to decrease HABs. I will just put this up here for the CSLAP volunteers. Hands up, those CSLAP volunteers. Anybody ever taken any? We thank you very much for all of your hard work. Here is some of it. And you can't see those grey dots, unfortunately, but there's take my word for it, there's a whole bunch of grey dots around here, which are other CSLAP lakes in New York State. I'll just talk you through this. There's total phosphorus on the x-axis from 0 total phosphorus up to 0.04. And on this axis, we've got chlorophyll. What this is showing you is that there's a direct relationship between the amount of phosphorus in your lake and the amount of chlorophyll in your lake. The more chlorophyll you have, the more phosphorus you have, the more chlorophyll. And here is Conesus, more or less in the middle of the Finger Lakes. On this lower graph, you've got Secchi disk depth. That's a measure of clarity. And see that at a Secchi disk depth of 0, you've got 0 clarity. Clarity increases as you go down here. And once again, you've got a relationship between total phosphorus and clarity. More total phosphorus, less clarity. And with less total phosphorus, for instance, Skinneapolis and Keuka Lake, they have Secchi disk depths of 7 meters, 8 meters. In fact, I will tell you, I'll leave that until later. So, HABs, how is the state government working on it? Well, we certainly are very integrated with the Office of Parks and Recreation and Department of Health. So DEC coordinates the reporting. And we host a system called HABs. Anybody use HABs here? That's the harmful algae bloom reporting tool, which I'll show you in a second. So we are pretty joined up. And in the last decade or so, there have been 650 lakes in New York State with confirmed HABs, out of a total number of lakes in New York State of around 10,000. So NIHABs, it's active from May to October. It is our main communication tool, and it was gratifying for me to see some of my personal friends actually looking at NIHABs to see where they thought they might go swimming. It is updated daily, and it's a tool where you can go and report a harmful algal bloom if you see it. Take a photograph, it knows exactly where you are, and it's eventually going to be registered on the system for everybody to see. A very useful tool. Now, I talked about the visual response. We used to do an enormous amount of sampling, analysis, and we've abandoned that process. And there are various reasons why we do it. You can have symptoms with or without a confirmation. The sampling and analysis took a lot of time. The logistics were crazy, even worse than CSLAP. The costs were high, and we couldn't analyze all of the toxins. We also found that there was a very good relationship between visual identification and analytical determination. So when you have a 97% accuracy, you can then start relying more and more on visual identification. So the mantra is know it, avoid it, and please report it. And this was a harmful algae bloom that was reported, I think, on Cayuga Lake. One of the problems with these blooms is that they are ephemeral. They're there one day and they are missing the next. So in particular, this was July the 16th. We sent somebody out there to take a sample, and this was what they found the day afterwards. The HAB is gone. I'm sure you've all seen that. They come and go, they get blown around. If the wind picks up, it mixes them back into the water column. So they're really difficult things to study in some ways. But DEC has some advantages here. We've been able to take that large data set, which we've collected, and this was a publication that was put together by Rebecca Gorney, who was with DEC. She's now with USGS, and some of my other colleagues. And we looked at the frequency of blooms. We found that since 2012, they definitely increased. They've reached 170 or so a year, and since 2016, the number of blooms that have been reported has more or less plateaued. We're not sure of the reason for that. It has been going up slightly every year, but it hasn't increased the same way that it was before. I put this down to observer bias. If you've got more observers, you have more reports. And this is one of the problems with this whole data set. How do you address that? If we have 10 times as many people looking for blooms, we might have 10 times more bloom reports. So that's just a difficulty with that data set. So one of the great things that we can do with that data is we can look back and think, what should we do? What's the best way to deal with this issue? We certainly need a deliberate HAB response approach. And that means going out with DEC staff systematically and looking for HABs as part of their other duties. But we are also interested in continuing this NIHABs surveillance and reporting. It is really a very useful system. We're going to continue to apply our resources to researching and understanding HABs. but we also want to do something about them. We don't want to just write reports and publications. We want to do something. And DEC has put in, and the state generally has put in hundreds of millions of dollars in dealing with this issue. And most of that has gone to controlling the controllable factors. In other words, phosphorus via clean water planning. We also are interested in trying to find out what to do about HABs once they're in a lake. Is there anything that we can do to take those cyanobacteria out? So for the next half an hour, 40 minutes, I'm going to go through those two aspects. Watershed management, I talked a little bit about that. I'm going to talk about that in a little bit more detail. We've got funding to deal with both of these issues, and I'll talk about that in a little bit more detail. The research and the in-water body mitigation. So watershed management, some people would say this isn't quite as sexy as developing lasers to take out cyanobacteria or things like that, but this is really fundamental. Planning for clean water and funding those projects for clean water. So clean water planning. DEC has a whole variety of different ways of planning for clean water. And it's not a one-size-fits-all. I mean, we've got 11 Finger Lakes. Each one of them is looked at, for instance, in a completely different way. And that's the reason why Conesus and Honeoye have TMDLs, total maximum daily limit reports, and others don't. Some, for instance, Keuka and Seneca Lake have 9-element plan reports. I'm not going to go into the differences here, but just to say that each lake gets the plan that it is most fitted for. Well, that's what we hope anyway. And many of these plans, or all of the plans in the Finger Lakes, address nutrients. How are we going to keep nutrients on the landscape rather than washing into our streams, washing into our lakes? And those projects that are consistent with the watershed plans get extra points during grant funding. And so if you have a watershed plan that meets these criteria, you're more likely to get funding for your projects. So the Clean Water Plan document the watershed characteristics. The main things that we're looking at are the geology, the soils, the slopes, and the watershed land uses. So you'll know that forests generate not very much phosphorus. Row crops on steep ground with erodible soil generates more phosphorus, more sediment. We're interested in point sources, like wastewater treatment plants, that kind of thing. And we would be looking at what level of pollution, for instance, nutrient or phosphorus, would allow the lake to meet its best uses. Now, the best plans are adaptive. They have strong implementation plans. They talk about, well, what are we actually going to do about this? And some of the plans talk about or include modeling, so watershed modeling, and also in-lake modeling. And what that allows us to do is to put into our models various scenarios. So we can model climate change, we can model increased precipitation or increased cover crops, for instance, and see what's going to happen to our nutrients on the watershed side and then the nutrients in the lake. So those models are very useful, they're expensive, they're kind of cumbersome, but they can be useful. So the short-term benefits, we can inventory the watershed, what is there. We can put together watershed monitoring programs. So lots of volunteers love to go out, take samples, ship the samples off to a laboratory. And that's very useful to get a baseline. We can quantify our nutrients, and we can also identify areas of concern. And these would be sources of sediment, for instance, nutrients, farmyards, rivers which are used by cows for drinking and so on. Things like that. And it allows us to come up with these science-based decisions. The long-term benefits, actually, I'm going to concentrate on this, building partnerships for extended effective management. To put together these watershed plans, you really need to be speaking to a lot of people, and you have to have a cooperative relationship. And these clean water plans do help with federal and state funding. You can see that there are an enormous amount of clean water plans across the state. It's a shame that this is a bit washed out, but anyway. The grant funding that is available comes in several different flavors. The NPG grant is up to $3 million a year, approximately $50,000 to $400,000 per project. And this helps with planning for mitigation measures. You can see that there are a variety of different report types that can be put together. Almost all of them are to do with either flood resiliency or keeping nutrients on the landscape. But the largest grant project that we have is the Water Quality Improvement Program, I think it is. Last year it was around $215 million of taxpayers' money, our money. And it went to a whole bunch of different projects, up to $15 million per project. And I should say that most of those projects seem to be wastewater treatment plant upgrades. Those can be very expensive. And also some of the other projects are to do with buying land, putting it into state keeping to allow that to be not developed. So for instance, over on Cayuga Lake, a huge tract of land was purchased by, I think it was the Finger Lakes Land Trust, through this project, which protected something like 500 acres of land which otherwise might have been developed. Now, I asked a colleague to pull this information briefly off one of our systems. Just for the Conesus Lake watershed, we estimated that in the last several years, around $3.68 million have been spent on watershed improvements. And the reason it's in draft is that there may be some other grants out there that we couldn't quite track down, but I think you'll agree that that's a pretty good sum for a small watershed. There'll always be more, but all right. So that is the state's approach to watershed management. All right, write the plans, get the grants, do the implementation work to keep nutrients and sediment in the watershed. What happens if the nutrients are already in the lake? What can we do about that? So the next part of the talk is going to be about water quality improvements and how that might help with HAB mitigation. Now, there are many possible strategies, and I've taken this figure from Pearl and others who wrote a very neat summary paper, and they got this really nice graphic. So here we've got nitrogen and phosphorus reductions. I already talked about that on the landscape. You could have increased flushing of your water body, enhanced mixing, which might be one of the projects that you guys are proposing here. And we could manipulate the food web. We could try ultrasonic treatment, which I will talk about in a second. And upstream wetland development, which has been successfully implemented in, I think, Honeyoil Lake. Chemical treatment, which I'm going to talk about in a second. Some people favor encouraging macrophyte growth, weed growth, to take phosphorus out of the water column and imprison it, if you like, in that weed mass. Then you take the weeds out and put them somewhere else. And then finally, you could cap the sediment, if the sediment is where the phosphorus is coming from, or you could even dig it out. Now, some of these are more successful than others. Some have been tried in New York State and others not so much. So what I'm going to talk about next is basically a method for trying to keep phosphorus, which is in these sediments at the bottom of our lake, right down there, so it doesn't come up into the water column. And we call that generally internal loading control. Other people would call it nutrient inactivation. And particularly, we have used a substance called alum, or aluminum sulfate. This was recently tried in Honeyoil. Anybody here from Honeyoil Lake? No, there's going to be a very specific presentation for Honeyoil Lake on the results of our alum treatment sometime in 2024 or 2025. But for your enjoyment, I'll just tell you how it works. You discharge this liquid aluminum sulfate into the lake. It causes the phosphorus to go onto these fluffy clots called flocks. And as the flocks settle down, they take the phosphorus out of the water column. And then as it settles onto the sediment, it's supposed to lock that phosphorus into the sediment. It's supposed to improve water quality. You're supposed to get better clarity and color and less available phosphorus for the blooms. And as you can tell, I've kind of given away the story, haven't I? Sometimes it's not always successful. One of the issues with alum is that it's quite acidic. And so if you put too much alum into your lake, you can induce aluminum toxicity for a start. The other issue is that you can actually decrease the pH of your entire lake. And so one has to be pretty careful and understand the water chemistry before you put in your alum. Now, some previous applications of alum have been put into a lake specifically to directly kill harmful algae blooms. And there is a real problem with that in New York State, because that would be a pesticidal intent. You would need a pesticide permit for that. And those aren't always straightforward to get. So in some of our projects, what we've done is tried to apply the alum outside that growing season, right? So in April, in October, in November, and that way we get away from that pesticide problem. So we've carried out a couple of alum pilot projects, and outside these pilot projects, there is no way for the public or organizations to get a permit for the application of alum. We tried alum on Peach Lake and Mohegan Lake, downstate, and then Honeyoil Lake later on in 2022. And what I'm really going to do is concentrate on Peach and Mohegan Lakes and tell you about how that went. So we wanted to really understand how to safely apply alum, make sure that it is an effective treatment, and we wanted to establish the criteria for a successful treatment. How much phosphorus is coming from the sediment, for instance? That's called the internal load. The external load is how much phosphorus is coming from the watershed into the lake every year. That's the external load. And we also wanted to work out the monitoring requirements. What do we have to monitor before and after to see whether it was effective? We wanted to work out whether the water quality standards in the lake were breached. And we wanted to understand whether that time of year application to avoid pesticidal intent, did that affect the efficacy of the treatment? Because those are cool times of year. April, I wouldn't go swimming in the Finger Lakes in April, right? It's cold water. Same as October, November. And just internally, from our point of view, we want to understand how to issue a permit for an alum application. And as you know, the bureaucracy, there's a bit of bureaucracy and paperwork involved with that. So initially what we did, we looked at historical water quality, we looked at the trophic indicators for those ecologists amongst you, phosphorus, nitrogen, chlorophyll. We looked at the health of the lake from a biological standpoint before and after the treatment. And we certainly monitored the lakes for their pH and their aluminum concentration while we were applying alum. Now, as we found, there was quite a lot of difference between these lakes in terms of their internal loading. So, Peach had 75% of the phosphorus coming from the sediment. Mohegan only had about half of the phosphorus coming from the sediment. The other was coming in from the watershed. Honeoye, on the other hand, 93% it's estimated that phosphorus is coming from the sediment. And that's a significant factor in the success of these lakes. Right, just a very brief overview. For Peach Lake, it's not a water supply, it's 242 acres, about a quarter or a fifth, about a tenth the size of Conesus, I would say. It had a clean water plan at total maximum daily load assigned to it in 2019. It's got problems with fecal coliforms, but it has relatively high total phosphorus. These are high numbers, particularly 160 micrograms per litre. In the hyperlimnion, that's the bottom waters. So certainly a candidate for treatment. Mohegan Lake, it's even smaller. It has a problem with phosphorus, and the absolute level is still relatively high, but a little bit lower than Peach Lake. Secchi depth of less than 1 meter. That's murky. Right, 2019, the dosage calculations, we won't have to go into all of this in detail, but part of the calculations are how much of the lake bottom is deprived of oxygen. In other words, how much is anoxic? So based on that, and some other calculations, it was decided to put in about 7 grams of aluminum per meter squared in Mohegan and about 11 in Peach. We did lots of water quality monitoring. We sampled phosphorus, chlorophyll, transparency, and we also looked at biological assessment profile, which is a terrible term, but basically how healthy is the lake in terms of its biology. And I'm going to show you now some of the results. Right, let me just explain what's going on here. This is for Peach Lake, and you can see that the pink colors are pre-treatment, was the lake like before alum was put into it, and the cyan color is post-treatment. So this is for the epilimnion, that's the top part, top layer of the lake. This is the hypolimnion, the bottom waters. And what we've got here is a box plot, which shows you the average, the median, and an interquartile range. What these results are saying is that for total phosphorus, there was no significant difference between the pre-treatment and the post-treatment in the epilimnion or in the hypolimnion. Again, there was no difference between the chlorophyll in the lake before and after treatment. But interestingly, there was a slight improvement in Secchi disk depth before and after treatment. All right, so that difference was about 0.6 of a meter. So we got mixed results on Peach Lake. This is for Mohegan Lake. In complete contradiction to Peach Lake, we got a difference in total phosphorus concentration after application. But we didn't get a statistically significant difference in chlorophyll nor in Secchi disk depth. So we really got some mixed results from these two lakes. Confounding results, annoying results. So in terms of biological monitoring, we went around and looked at basically, did we do any damage to the lake? Did the biology improve? Peach and Mohegan Lakes, once again. But we also looked at these biological scores for some other lakes which didn't have an alum treatment. Those are our control lakes. And you can see that on these two panels, we've got the pre-treatment score in dots and the post-treatment score triangles, and then the squares are controls. Well, basically, there was almost no difference in the biological scores pre and post-treatment, which in some ways is good. We didn't do any harm to the bugs in the sediment. There are no apparent toxic effects of that alum application in the treatment lakes. So in summary, for Peach and Mohegan Lakes, no change in total phosphorus or chlorophyll A. Peach Lake, slight increase in Secchi disk. Mohegan Lake, we did do something to the total phosphorus, we decreased it. No change in Secchi depth or chlorophyll. So once again, it was very mixed effects. And those were not cheap. Pilot projects. One of the things that we think is that the dose methodology resulted in a gross insufficient dosing of alum, very low dose. Mohegan didn't have all of its external phosphorus addressed, so as we're trying to deal with the internal phosphorus, there's more phosphorus coming in through the watershed, and there may have been some interference with the treatment because of heavy rainfall. So DEC's experience with alum was really mixed at that point, I think it's true to say. And then a colleague of mine arranged for alum treatment on Honeoye Lake, your close neighbor. It was a $2 million budget. Honeoye Lake is a water supply. It's one of the larger lakes that alum has been applied to in the northeast. And it does have high phosphorus, particularly in the hypolimnion. We chose an updated, more modern way to calculate the dose. And you can see that the full effective dose down here For the deep part was 82. When you think back, Peach and Mohegan, they only got about 7-10 grams per meter squared. So these are much higher. However, our project was limited by a couple of things. One was you can't put too much aluminum into your lake, otherwise you're going to acidify it, turn it toxic. And the other is cha-ching, cash. Putting in this amount of alum would have cost around $8 million. So I'm not going to spoil the story for the Honeoye folks. We're still waiting for some of our biological monitoring data, and we are going to talk about all of those effects. I think there's no secret that, once again, alum didn't have a discernible effect even on Honeoye Lake after $2 million worth of state investment into it. But we'll explore those results in a specific meeting. This was a picture, by the way, of alum being applied to Honeoye. So what we're going to do, we are still trying to work out how to do this permitting strategy. We want to address the criteria for eligibility for alum projects through water quality improvement program. So can a community like this apply to WQIP and get tens of millions or millions of dollars to do an alum application on your lake? Now, how do we establish that? It's been made much more difficult, I think, by the mixed results that we've seen so far. And we're also looking at the monitoring requirements and how we can put that into a specific permitting pathway. All right, on to our next way of mitigating a HAB. This was a project that DEC funded. It's called electrochemical oxidation, and it's the subject of a paper that has just come out in a Royal Society of Chemistry publication. It's to do with how you pass electricity through water to generate or to treat the harmful algae bloom. I'll go through this briefly. So what the team did was design a reactor with electrodes in it, and passing electricity into those electrodes caused the water to break down partly. Some of the water turned into hydroxyl ions. Some of the natural chloride in the water turned into chlorine, which you know is one of the ingredients in bleach. And some of the oxygen turned into ozone, which is another powerful oxidizer. And what that does is it disrupts the cell membranes, it oxidizes the carbon in the cyanobacteria, and it also breaks apart the toxins that might be found there. So this project went through a variety of different prototypes, from bench scale tests like this one, where they passed electricity through different alloys. It went through porous electrodes. Eventually, the electrodes started to look like this to prevent clogging. And this is the reactor with parallel sheets of anodes and cathodes. Now, one of the problems is that if any of our lakes here have got natural chloride in them, once you break that chloride down into chlorine, it reacts with the organic or carbon-containing compounds in the water, and it produces these things called disinfection byproducts. Now, some of those you might have heard of. Chloroform, right, is what naturally occurs if you are chlorinating a high carbon water body. There are these other rarer the more exotic versions, trichloroacetic acid and so on. And they are allowed in drinking water, but up to a maximum concentration limit, which I've marked here. And you can see in the field trials, Lake N and Lake O, some of the effluent from the experimental reactor actually had concentrations of these disinfection byproducts which exceeded the maximum allowable concentration. But it was discharged into a lake and immediately diluted. The team also eventually decided that this value, 7 milliamps per centimeter squared, was the best treatment level, and it also decreased the amount of disinfection byproducts. This is one of the experimental setups. You can see there's the reactor, there's a very large generator which is producing lots of electricity, and this is basically what it looks like. This is the control, which is raw water from the lake, and this is post-treatment. And you can see that there's a discernible change in color, even at 700 amps, 1,000 amps, that's possibly even greater. Basically, the team is claiming that one can remove up to 90% of the chlorophyll in that lake water at 100 gallons per minute. Now, that seems like quite a lot. However, when you look at how many gallons there are in one of our lakes, you would not be able to measure the difference if that guy was out there treating the water 24/7, 365 days a year. What this technology would be good for would be for treating a HAB in a cove or some enclosed space. There you might see a discernible difference. Now, Clarkson University, with the lead researchers on this, they're trying to commercialize the technology. It's kind of difficult for them to make the numbers work, though, because of the expense of this technology, how often it's used, which is not all that often, probably a couple of weeks a year. And one of the problems is that when the HAB season starts, everybody wants one of these. So, renting them out is difficult. All right, so that was electrochemical oxidation. That's a brand new method. It's peer reviewed and it's under development still. And I'm going to give you one final case study of a harmful algae bloom mitigation method, and that's ultrasonic. Can you see here? Lake Welch is what we would call downstate, but folks in Manhattan would probably call upstate, right? Because it's so close to the city, it gets an astonishing 320,000 visitors a year. It's tiny compared to our glorious parks up here. It's mostly forested, but it does have the disadvantage of a wastewater treatment plant discharging into the lake. All right. Now, surprise, surprise, there was harmful algae bloom in 2022, started in June, didn't finish until October, right? Turned everything green. They had discrete harmful algae blooms, and they had to close the beach. You can see nobody on this beach. And for those folks from the city, that's not great. So it was a kind of an emergency response. What are we going to do? And with the Office of Parks, we did a two-pronged project. One, how much phosphorus is coming into the lake? Where is it coming from? We also had to evaluate this idea of ultrasonic treatment. All right, so this ultrasonic method, these are what the units look like. They're solar powered, and they have these transducers dangling in the water, sending out beams of ultrasonic sounder energy, which are supposed to disrupt the cell membranes of cyanobacteria. They have an effective range, obviously, because sound doesn't continue to travel all the way through forever. So they have a range. And what, let me just make sure. So here are the treatment ultrasonic devices. We also had some sample points away outside of the zone of influence where we could see whether the water body changed despite being outside the zone of influence. So it was a relatively good experimental design. Now, for the 2022 treatment, you can see that the open boxes are the controls, so outside of the zone of influence, and the dark boxes are the treatment, so close to where the ultrasonic buoys were. Well, there was very little difference around the 26th of July. The buoys were installed, and then immediately the values decreased. But look at that, the values decreased both next to the buoys and far away from the buoys. So as a scientist, one would have to draw a couple of possible conclusions. One would be that the zone of influence is actually bigger than was estimated. Or you could say, well, the entire lake decreased in cyanobacteria concentration, whether it was close to the buoy or not. So for other reasons. And so this was once again a result which we couldn't readily interpret. The next season was a little bit less of an emergency deployment. The ultrasonic devices were installed in April, and they went all the way through until September. What you're seeing along the bottom here is the concentration of phycocyanin, that pigment that we see in cyanobacteria. And so you can see that it actually spiked around this point, middle of June, despite the ultrasonic devices being there. At that point, the Parks Department decided to deploy algaecide into the lake. They poured in a copper-based algaecide, and that really knocked down the rest of the blooms for most of the season. So, once again, what can we conclude from that? It's really not very clear whether the ultrasonic devices worked or not. So, in that mealy-mouthed style that scientists have, they would say, this study cannot definitively state if the ultrasonic devices reduced or enhanced the concentration of blue-green algae and their toxins. But let me tell you, the feeling inside DEC is that ultrasonic devices do not work in large lakes. They might work in small drinking water reservoirs. Apparently, there's lots and lots of data from the Syracuse water supply system where they have ultrasonic devices, they work. So, those are the three HAB mitigation techniques that I wanted to tell you about: alum, electrochemical oxidation, and ultrasonic devices, right? Almost finished. So in terms of HAB research, DEC has really, I think, been quite active on this. The general research that we've been doing on HABs has included a research guide, which sets out what we think are the priorities for HAB research. That has money attached to it, but it's not been sent out for a request for applications yet. We've put together action plans and a variety of different general research projects. I will say I'll highlight this one, remote sensing, satellite paired chlorophyll and phycocyanin. We've just had a paper out on that, which once again uses CSLAP data. Thank you very much, CSLAP volunteers. And it's just out in remote sensing, if you are interested. But in particular, in terms of mitigation, we've looked at ultrasonic devices, not just in Lake Welch, but in Lake Carmel and Lake Agawam. And we've looked at these, we've funded an in-lake feasibility study for Honeoid Conesus lakes. And we've also funded electrochemical oxidation and hydrodynamic cavitation, which was an ESF project, which was not found to really work. All right, here's my penultimate slide. So just to remind you, cyanobacteria are a natural part of a lake ecosystem. Problem is when they generate these balloons. Now, in order to decrease those balloons, we need to keep phosphorus out of our water bodies. And DEC is really committed in terms of resources, people, money, in managing those nutrients and the HABs that come along with them. We've got long-term plans, we've got short-term plan as well. Basically, we're interested in nutrient reduction and funding, significant funding to support those efforts. And we're also very active in terms of monitoring and assessment of these water bodies, research, permitting and reporting of HABs. So in terms of HAB mitigation, specifically internal loading controls, alum and associated chemicals, we think that that is going to be permitted venture, but on specific water bodies. Electrochemical oxidation, very new, it's innovative, but it's limited in scale. And it's probably a bit expensive, for instance, for a lake association. So there are other HAB mitigation technologies out there. I talked about lasers earlier on. I wasn't making that up. There is a device that is an autonomous robot which goes into your lake and uses lasers to take out cyanobacteria. It got an incredible amount of funding, and I've yet to see any peer-reviewed papers showing that it is an effective method. Likewise, there are lots of people out there which will sell you magic beans, which will sort out your HABs. They are not proven. And until we see some solid experimental design and quality assurance in terms of water sampling before and after, within the zone of treatment and outside, and also a peer-reviewed publication, those really are just basically magic beans. Okay, I'm going to wrap us up there. Thanks very much.
Another question about that alum treatment. If that had worked better and you had, really successful results, is that a one and done? Or do you have to put that more of that every year or every 2 years?
Yeah, so the question was, is alum treatment a one and done? And what the experts have told us is that if you put in the full effective dose, you should see a decrease in phosphorus for 5 to 10 years before you have to repeat that dose. That's what the experts have told us. They also told us that we would expect to see some decrease in phosphorus, even if we put in a quarter dose. And to be honest, we didn't see that.
And what does alum do to the fish population?
Alum, if you apply alum at the right concentration, so without decreasing pH too much and increasing the aluminum, should have no effect on the fish population. Yep.
Explain the TMDL. You referred to it as something minimum, maximum daily limit, but what is it? And why is Conesus under this TMDL? And it's a high level of what, monitoring, or could you explain that?
Yes, so question was about TMDLs. So that is an acronym for total maximum daily load. And it is a clean water plan which looks quite hard at where the inputs of the pollutants are coming from. So for instance, wastewater treatment works, industrial plants, agriculture, septic systems. And it works out using modeling what is the maximum allowable pollutant concentration allowed in that water body for it to meet its best use. So for instance, Conesus has a TMDL. The pollutant of concern is phosphorus. And the report was written calculating how much phosphorus can we allow into the lake for it to meet its requirements as a drinking water source. And what that then allows DEC to do is if we have permits allowing a wastewater treatment plant to discharge too much phosphorus into the lake, well, DEC is able then to ratchet down that limit so that the amount of phosphorus going into the lake decreases and the concentrations decrease in the lake. And so that was put in place in 2019. I personally don't know if permit limits decreased around Honeoye, but I do know in other cases permit limits will be decreased when TMDLs are enacted. Does that answer your question? Yeah. Okay.
And along similar line, you're saying that it's just a model, or is there a finite TMDL that should be going into Conesus Lake? And has it been determined those sources?
Yes, absolutely. So it is a while since I've looked at the TMDL for Conesus Watershed, so forgive me, I'm going to still have to talk generally about it, but the process is that all of the sources of phosphorus would have been looked at, calculated how much is going into the lake on a daily basis, the maximum daily limit, and then we look at the target for that pollutant, and then see how much we're going to have to adjust the inputs to get to that target. Yeah. I'm gonna, yep.
Louis, are you aware at all that Monroe County Department of Health applied alum to Irondequoit Bay since decades ago in the 80s or 90s? Did you know about that at all?
I didn't know that the OH applied alum to Irondequoit Bay, no.
Okay. I don't know if there's any paper published on it or anything like that, but it might be worth, looking into just in case it's one more data point.
Yeah. Gene?
Another question, but regarding Irondequoit Bay, they did do the alum treatment. They shut down a wastewater treatment plant that was draining into the bay. And for many, many years, they injected oxygen year round. And so it was effective, all those things, but a lot of people seem to think that alum was the reason Irondequoit got cleaned up. Probably not.
Yeah.
Took off all the little sewer treatment
Yeah.
just before.
Yeah.
The question I had was, it seems like the HABs have increased worldwide on all kinds of lakes, some in remote areas, no development and so on. So that raises the question, is there something common happening worldwide? One of the things associated with climate change is increased CO2 levels in the atmosphere, which has skyrocketed since about 1950. I notice now the EPA indicates formally that CO2 is one of the causes of HABs. And I don't know if New York State DEC has looked at that or is aware of it or has taken a position on that.
I would love to see that paper. I would love to see that reference if you wouldn't mind sending it to me. Yeah, I mean, increased CO2 in the atmosphere is well understood to increase plant growth, and these are plants, after all. So increased CO2 in the atmosphere is going to increase the concentration of organic carbon in your water. It'll decrease the pH as well. I wonder if increased water temperatures are also favoring cyanobacteria, because we do know that water temperatures, the cyanobacteria love warm water. In fact, the jury is out on whether HABs are increasing worldwide. There have been some contradictory papers. There's a paper by Ho and others which talks about an increase, but there are other papers which talk about a decrease in various lakes around the world. So I think the jury is out a little bit on that. My view, and I said it before, is that we've got observation bias in our data sets. Unless we can use something like satellite imagery, which is unbiased, there are more people out there looking. There are more people who have been trained to look at HABs, and we have provided. We've all got cell phones. We've all got high definition cameras in our pockets to take pictures of those HABs. So with more people out there, we're going to have more reports. So I really do think that it's a mixed picture.
I got a couple of questions or comments, three, I guess. I worked for DEC for the better part of 4 decades, but I remember watching some YouTube videos about what Chautauqua Lake did. I think they do they're pretty aggressive in their weed removal, and I thought they had a skimming thing going with algae too. Was that something that is true, and was it at all effective?
Yes, that was another HAB mitigation method that I could have included, but I only had a short amount of time, although it might have seemed quite a long time for you guys. Yes, Chautauqua Lake, I believe the habitats module was put out there. That was the Army Corps of Engineers put on a system which basically collected surface scums, and then they bubbled air through them to come up to the surface. Then they scooped off that scum, and then they hydrolyzed it and turned it into biodiesel. So it was a really cool project, but it had a couple of problems. The first prototype was built on the shore of the lake. It's pretty huge, high energy intensity. And the year that they had it on the lake, there weren't any harmful algae blooms. The year that they then put it onto a barge, towed it around, I think that was more effective. So the federal government has got tens of millions of dollars for these experimental systems, and I think one was tried out on Chautauqua Lake.
I guess, and then you mentioned weed removal.
Yes.
Seems to be effective. I know we don't really look at that as a priority here, recently at least. And then the other thing I wanted to comment, I'm at the south end where probably most of the phosphorus comes into the lake. And it's 10, 20 days out of the year, you probably get 90% of it. You know, those high flow days in the spring, for the most part.
Yeah.
And I don't know what could be done there. There are some ponds down there that I don't think they're particularly effective in the fish breeding. I'm not sure what the current thought is on that, but I don't know, you know. So just throw that out there.
Yeah, I'm agnostic about weeds and weed removal. I think you've got to look at the mass of the weeds that you'd have to take out of the lake. That is going to be one huge stinking pile of rotting weeds in somebody's backyard. And nobody wants that in their backyard, because you've got to take it out of the lake.
Yeah, we did it for a number of years, and I don't think there was a problem getting rid of it. I'm not sure what they did with them. People may know more about that history.
But yeah, it'd probably make great fertilizer. I mean, it's full of phosphorus, that's why we're taking it out. Yeah.
Part of the other issue with that is that oftentimes, macrophytes will divide and spread. So if you go in with a harvester, which they're somewhat common in some other lakes, that they end up distributing rather than solving. So I think our history here has been that it wasn't going to be beneficial in the long run, but it might feel aesthetically better in the short run. It's not part of our watershed management plan.
Right. Interesting. Sorry, that was.
Yeah, I wanted to ask, do people add phosphorus to the lake if they dedicate to the lake?
Yes, yeah, absolutely. And if they pee in the lake, it adds pee.
Yeah.
Yeah. No, it adds phosphorus.
I think coming to this lake despite my youthful here, 74 years. And I remember this lake before there was the New York State boat launching, which brings hundreds of boats to the lake every weekend. And it's around because the fishermen come in the morning and then the recreational boaters come in the afternoon and some of them leave and go back. Those people, I shouldn't say those people, they do bring with them boatloads of people who are probably defecating because they're not coming into the boat launching just to relieve themselves at the relief station there. I remember this lake before it had HABs, and you could see down 20, 30 feet to the bottom. So I really think an experiment would be to close the boat launching for 5 years and see what happens. That's my opinion.
Closing the boat launching for 5 years.
I'm sure New York State would not like that supposedly, but I think it would be something to.
What about increasing access to public restrooms for voters?
Well, do you think voters are they're out in the middle of the lake, you think they're gonna come all the way to the boat launch, get into the jam that's always there to send dock and let somebody go in? I don't know, unless you put something in the middle of the lake. Resting.
I was suggesting maybe the park here. Or
Yeah, a great facility at Long Point Park. And here too.
Yeah.
making
Well, I don't think anyone monitors, do you have a pee cup in your boat and is it full when you return? Because I know those people, they're defecating in the lake.
Defecating or micturating? I think we should be told.
Yeah.
Anyway, let's not go down that.
I think it's a very important thing to go down because this is contributing to HABs in the lake. I'm thinking there's hundreds of boats that are launched every weekend.
This would be a really great opportunity to capture the public's concerns as we're asking for input on the watershed management plan. I'll give you a little postcard before you leave, but this is the kind of stuff that we want people to say, here's my concern. And so that we can look at that and then put it all together. It's judgment free, right? I'm not evaluating it, we're wanting to know what people would like us to address. So,
It's an interesting point you bring up. I've never heard that. So thank you very much.
geese I've heard.
Yes, geese. We just have a last one or two questions.
Can you speak a little bit to toxins? Some of the questions I have are, when are they there? When do they actually appear, so to speak? How long are they there? And where do they go?
Those are all really good questions. So one of the disturbing findings of some of our DEC research is that you can have toxins in the lake before you have visual HABs. Now, these concentrations are pretty low concentration. I think part of that might be that, for instance, you have these picocyanobacteria, which are really tiny bacteria picocyanobacteria, really tiny harmful algae bloom organisms that you can't see quite as much as the other larger colonies, but they still could be toxin producing.
All the time,
No, they would also have their season as well.
so there's a condition that has to occur.
Yeah. I think that that's something that we'd love to have more research on and that we're willing to finance. So I think we've been in discussion with some of our local academic colleagues to talk about that. The toxin producing gene is present in some of these species, but as we've understood more about gene expression, we know that genes can be switched on or off to produce that toxin or not. We're not exactly sure what the environmental conditions are which switches on that toxin gene. There have been suggestions that the concentration of nitrogen is important for toxicity. I'm interested, but I'm not an expert. But there is there's papers out there which talk about that. Now, how long do the toxins last for? We know certain that they're gone by winter. They're organic molecules, so they will be broken down by natural processes, sunlight, scavenging by actual bacteria, that kind of thing. So we don't think that they're particularly long-lived once they're outside the cell membranes. Last question.
Okay, Louis, how many people are poisoned or, get sick from toxins, say, every year in the US?
I'm not a medical doctor. I'm not really familiar with the medical literature, but my understanding is that it is not a lot of people experience acute cyanotoxin poisoning. But there are every year reports of animals affected by cyanotoxin. So those would be particularly dogs which go into lakes with blooms, they come out, they then groom themselves. They lick their fur, that concentrates the bloom, they get toxins that way. I've heard some apocryphal stories about wildlife, so geese and swans which have been affected. And of course, over on the West Coast, there have been some reports of seals being affected by domoic acid, which is a toxin produced by marine cyanobacteria, which has caused them to have changes in their behavior. But that's marine HABs rather than fresh water. So I think acute toxin poisoning is pretty rare in people. My concern is chronic toxin exposure. And that's much less studied, I think.
Thank you.
Okay, thank you very much.
Louis, you've been a frequent visitor to our giving presentations here, and we certainly appreciate that. We should give you frequent flyer mileage.
Yes, sir, please.
Yeah. I would like to mention one thing before I came. Mary, this is the Watershed Management Plan from 2003. Mary talked about updating it earlier. No mention of HABs as one of the main factors affecting the lake.
Funnily enough, in the 1970s, there were HABs, but they're just called nuisance algae blooms.
As you can see, Louis is an excellent presenter. And I remember specifically when you were here 2 or 3 years ago, I don't remember the time, but I remember one of his statements that I thought was very pertinent. He acknowledged before he gave the presentation that he did not prepare the PowerPoint, but he was giving it on for somebody else. And he said it sounded kind of strange to do that, but the reality is, even though it was uncomfortable, it kind of worked. Like wearing underwear. Somebody else's underwear. That's right. So I'll always remember Louis for that, if nothing else. Thanks. So we'd like to give you our certificate of appreciation here. You can hang on your wall with all of your other Nobel Prize
Thank you.
Stuff like that, and
Nobel Prize probably. Thank you, Jean. Thank you.
Thank you. And one more handshake, that's.
Well, Jean,
One more handshake. I have to say, the last time that Lewis did a handshake like this, it was with Charlie Braun. And
Yes.
it ended up in the newspaper, so you never know
Ah.
when Lewis might show up.
yes,
Thank you, Jean.
yes, bless his memory.